Hi, everyone, and welcome to today's quick tip. I'm Chris, and I'm here with Mike. And today we'll be talking about linearization and profiling in Ergosoft. So, linearization is probably a term that you may have heard before if you're not familiar with it, but we want to start by just explaining what it is and why it's important. So, first and foremost, getting a good linearization on your printer essentially sets its calibration for the future. So, you set your initial calibration on your machine, and then moving forward, you can continue to restore it to that originally calibrated state. Also, it establishes the maximum channel limits for your primary channels. So for all of your profile colors, whether it's CMYK or CMYK plus N, you're getting a new 100% of that ink, which has an impact on your color, and ultimately the quality. And then finally, you're also achieving the smoothest possible transition from 0 to 100% of those channels. So it's very important for a lot of different reasons. And profiling, as you probably know, is going to establish the size and the shape of your color gamut. So the color that you can achieve with your printing system, if you're using process colors, is going to be governed by your ICC profile. So, quick spiel on what that is and why it's important, but it is pretty critical and central to achieving the color output that you want to achieve. So, Mike, it's going to be a complex video series for this one. There's a lot to go through. So take us from the beginning and let's start with the initial density linearization.
Thank you, Chris. One of the first things you need to do when starting with linearization is have your print environment set up. What I mean by that is your resolution, if you're doing 300 by 300 or 600 by 600, or if you're doing 6-pass or 4-pass or 1200 by 1200 or unidirectional, bidirectional. The point is there's a lot of options, right? And depending on your printer, you're going to have different options. Those options are going to be located here in the quality tab under resolution, or in the device options tab. You'll have a bunch of options in here. That's where you're going to set up all of the options. And the main reason you want to have all of this set up is because when you're in production, after your profile is built and your linearization is done, you want those settings to be already set up because you want to do your density linearization with your printer printing how it's going to print during production. Another thing you need to do is set up your spectro in the application defaults, which is in here, and go down here to spectrophotometer. Now, if this right here is set to from file or a different device, you just want to select your device and detect it. And once it detects it, just hit OK. And then you know that your Ergosoft is set for your device. So you want to make sure that we do that as well. So after that is done, we're going to jump into the actual linearization. So let's jump in. The calibration menu right here is going to be our best friend during this whole process. We're going to use this a lot. So density linearization is the first step. Click density linearization, and this window pops up. Right in the middle, geometry is where you select your spectro. Again, if you already have it set, it should be set to your spectro. You should see it listed here. But if it's not, I will just show you real quick. There are a bunch of options in here. A bunch of different X-ray devices, Konica. You can see, and there's also Barbieri. Now, if you're using a Barbieri device and you don't see it in the list here, you'll need to download the extension from our user portal. In the download section, you'll see an extension on there for third-party devices for Barbieri. So you'll see it on the download section. Once that's installed, you can select it. But the point is, you need to have your device selected here. We're going to use the narrow ruler, and we're going to use 9 patches. Now, the reason we're doing that, as you can see for the X-Rite device, which is what I'm using, the X-Rite i1 Pro 3 Plus, The Plus has a wider aperture than the regular i1 Pro or the Pro 2 or the Pro 3. The Plus has a wider aperture. And we're using a narrow ruler because that's going to make the chart a little more narrow, which is just my preference. This is what the ruler looks like, just to show everybody. Just looks just like that. But if you're doing, if you have an i1, a regular i1 Pro, you can select this option here. If you have an i1 Pro 2 or 3, but not the Plus, you can select this or this. The best thing to do is use the ruler. The ruler helps you make accurate measurements, doing the whole row at once, which is very nice to measure a whole row in one pass, which we'll show you in a little bit here. If you have, a different material, let's say you're profiling on a material that's like a phone case or a mug, or maybe maybe tiles, right? Like a little 6x6 tile. A lot of these charts won't fit on there, so let us know. Send us an email. We might need to do some training to kind of teach you guys how to make that fit and how you're able to profile that material. But for this instance, we're going to choose i1 Pro 3 Plus narrow ruler and 9 patches. You can see here there's an option for 9, 18, and 36. The 9 patches is going to be per channel. So you're going to have 9 cyan, magenta, yellow, black. Let me show you the chart. So normally what I would do is you would just hit print right here. I'm going to actually do that. But I'm going to check edit job before printing. This will allow you to actually see what's going to print before you print it. So I'm going to show you that real quick. So let's hit print. And you'll see it'll generate a chart name. And it gives you this message saying that it ripped the chart. Any modifications to the chart job might impact the calibration. So what that's doing is it's giving you a warning not to change the chart. You're just kind of looking at it to see what you're going to get, right? You do need to save this if you're doing the edit chart before printing. So we're going to hit save. And now you can see we have this chart here, right? This is what the chart will look like when it prints. It'll have a black square, and then it'll have A1 through A9, and then B, C, and D for the different channels. What the Spectro sees is when you slide across, it sees that big black patch, and then it sees the contrast between that and the next patch, right? So this next patch is white, so it sees the difference and then it measures, and then it sees the black line, and there's a lot of contrast between those, right? And then it measures again. So you measure across, and you have the line measured. I'll show you that in just a moment, but this is what the chart looks like.
That's a very good point, Mike. Quickly, for anybody doing this process for the first time, is that the black square on the left and the white square on the right is also letting the Spectro know that a row is starting or is complete. So it's critically important to ensure that you're measuring the entire width of each row so that the Spectro knows when to begin and when to end. So if you don't measure it in the full width, it will give you an error.
Correct. Yeah, no problem. So once that's ripped and printed, you can see here it printed through. You can go back into the density linearization. So calibration menu, density linearization, and it will still have your chart here listed, and we can click measure. So that's what we're going to do. Now, we should already have our Spectro set up. We set that up previously in the default options. So we're already set up to the X-Rite Pro i1 Pro 3 Plus. So we're going to click measure. And for the i1 Pro 3 Plus, that's this guy right here. This has a patch to close this. So this needs to be open. This needs to be on there. And then it's going to calibrate onto that white patch. Once it calibrates, it pops up your measurement window. So now the next step literally is to measure. Here is our chart. You can see here it starts with the black patch and it ends with the black line. Each row is going to start with the black patch here and end with a black line. So we're going to scan from
to the left of the black patch all the way past the right of the black line. We'll talk about that more in just a minute, but here is the ruler. So to align your ruler, you want to line it up at the bottom of the row of patches. So you can see this is the line. There's a clear piece here. So I'm lining that up right at the bottom. Just like that. We have our spectro here. It's already calibrated and everything. And we're going to take this, and there's two little notches here, there and there, that go into the little nubs. There's two little nub things on here, and this sits on there like that, and the whole thing will slide. It won't really move too much, but it'll slide. So then what we do is we push the button on the side here, right there, and you hold it, and you'll hear a beep. So you put it to the side. You want to start it. Once again, I'll show you this. So this is the aperture. So it's in the middle of the device. So what we need to do is put the middle of the device sort of to the left of the first patch. So I usually just put it so I can see the patch there. And we're going to push the button and hold it until we hear the beep. Slide it about this fast. And then you want to finish past the line. See it? And let go. And then you look at the screen. You see if it moved, if it changed from needing to scan the first row to needing to scan the second row. I see it did change. So then all we do is slide this down to the second row, slide this back, past the patch, right? Push the button, hold it for the beep, slide it across, past the line, and let go. And what Ergosoft is doing is, I think I mentioned this earlier, but it's seeing the contrast between all of these patches and the lines in between. So if you don't measure all the way across, or if for some reason it doesn't see all of the patches for some reason, it will give you an error message, unexpected number of measurement values. So for instance, if we go like this, push the button and hold it, start measuring, and then stop. See, it gives you unexpected number of measurement values error. Also, if you go too slow, like this slow, is probably too slow. And then this fast is probably too fast. There is a fine line of how fast and how slow you can go. I usually go about this fast, like that, and that always works for me. So let's move this down to this patch here. We'll scan this. There we go. And then we'll go to the last one here. Pass the patch here. Push the button, hold it, hear a beep. Slide across, let go. There we go. That's basically it. Put this back on the calibration thing to protect the aperture and the lens. Clean up your desk and you're good to go.
As you can see here, it says measured to. So I measured it a second time. I'm going to save over my data just so I have that for later. But this is what I was saying, how you can compare the measurements, right? So now that you have two sets of data, you can see on the right here, you have your LAB for each measurement, measurement 1 and 2, and it gives you a delta E, right? It gives you delta E, 0.16, 0.04. That's really good. You want the delta E to be very low. What that really proves to you is that both of your measurements were accurate. We do have an option here called highlight deviations, where you can have it highlight anything with a delta E above a certain level. Right now it's set to 1. I want to do 0.5. Nothing is highlighted. I want to show you like 0.1, right? So all of these are above 0.1, which is a very small delta E. So if I do 0.2, 0.3, so nothing is above a delta E of 0.3. That's what
So
the
this
highlight
is
deviations will do. Yeah, go ahead,
this
sorry.
is just making sure that each measurement process, each chart scan is the same as the other one.
Yeah, it's basically proving to yourself and Ergosoft that the first measurement was accurate and the second measurement was accurate. With all that measured in, all of our delta E's are good, everything is great, we're going to hit OK. That brings up the curve. Now this curve is a representation of the data that we just measured. It shows us our density here, 1.35 for cyan. I'm going to show you all these real quick. Magenta is 1.3, black is 1.79, yellow is 1.39, right? So it shows you all that information, but for the first linearization that you measure, like I said earlier, it's basically just a baseline, right? Where you're not really going to change anything. If you want to click compare measurement with target density, you can. It'll put a line beneath your curve and it'll show you where Ergosoft wants the curve to be and where your data is. As you can see here, we're pretty good right now. Sometimes in certain applications, you might have, like I said earlier, where the first patch jumps up really quick from like 0 to 80% really fast. That's what this first one is doing, is basically setting a baseline so Ergosoft knows that it needs to adjust and bring all those values down to your target. So for the first linearization, I don't change anything. I recommend just measuring it and hitting next. Don't change anything. So that's what we're going to do. Hit next. Dot gain, we can talk about this more later, but basically it's kind of a standard 20. It's equal for all channels. Cyan, magenta, yellow, black are all the same. We're not going to mess with that right now, so we're just going to click next as well, and then finish. And now we have the first linearization chart measured. Creating the second linearization chart is slightly different. So let's jump into the calibration menu, density linearization. And we're going to do the second amount of patches. In this instance, it's 18 patches. So it's going to be just like the first chart. I'm going to show you the chart just so you get a visual for it, but it's going to basically have 2 rows of cyan, 2 rows of magenta, yellow, and black, and magenta. So since everything else is set up, your geometry and everything, all you have to do is change the patch count and hit print. I'm going to do that. So here is our chart. So as you can see here, you have 2 rows of cyan, magenta, yellow, and black. So it's the same as before, except there's 2 rows. So when you go to measure it, you just measure A1, A10, B1, B10. See on the left over here, C1, C10, D1, D10. It's the only difference. So let's send this to print. Print, I don't need to save the job. Send that to print, printed it. So once it's printed, you go in to measure it. So you go to the same menu, calibration menu, measure. And with your new chart, we're going to measure it in. Okay, so once you measure it in, and you have 2 measurements, because we always want to measure twice. Once you measure it in, you can take a look at your measurements, make sure they're accurate like we talked about before, and you can hit OK. Click OK. The next step is taking a look at the curve here. This information shows us our data plotted on a graph, on a curve here. You can click compare measurement with target density, and it shows you there's a little black line underneath here, and that is the target. That is what Ergosoft wants your linearization curve to look like. So as you can see, it's very close. And that's what you're looking for. On the second linearization, if you're very close like this, for instance, this is magenta, this is yellow, and this is black. You see, they're not all absolutely perfect, but they're very, very close. I would say this is about as far as I would leave it. If your data is further from the target, maybe twice as far off of the line, I would do a third chart. Same thing we just did, except a third chart. Other than that, we're fine. We can continue. So once you've looked at your curves, made sure everything is looking good, we want to apply a channel limit. So right down here on the bottom, there's an auto limit button. We're going to click that button and you'll see this red line that it puts in. Now what that's doing is Ergosoft is looking at your density and it's picking a point in which it thinks it's good to limit your channel. Now each channel is going to have its own limit. For instance, this one is at 1.459. This one is at, down here on the bottom, see 1.304, yellow, and then black. Black is more dense, so it's higher, as you can see, 1.8. You are able to limit these manually if you have your own method for selecting your channel limits. You can pick a patch. For instance, if you wanted to limit black at this patch here, 1.529, you can click that patch and then click limit at selected patch, and it will move the line down there. As you can see, it doesn't move the curve down to it, but once you hit OK, it will bring all those values down to match the target. But for now, we're going to leave it at the auto limit values. And what you're really looking for on your chart is you're looking for the point in which each channel starts to become, for instance, the cyan channel, it stops becoming more of a dense cyan and it basically turns blue. Yellow, magenta is going to turn more reddish as opposed to just darker magenta. Yellow turns more of a gold instead of a darker yellow. Black is a little harder because it's still black, but you can kind of tell at a certain point it stops becoming more black. It just stays the same. That's kind of where you want to limit. That's what Ergosoft does. It uses the information from your linearization to calculate at what point that's happening.
I think this is also a good point to talk about ink savings as well, because essentially what you're referring to is there's this law of diminishing returns that takes place where you're continuing to lay down more ink, but it's not having any improvement on your color. So by utilizing the auto limit, you're creating a scenario where you're building in the maximum color density without laying down ink that's not going to do you any good.
Exactly. So that's what this is for. That's what the auto limit is doing. Click auto limit, just take a look, make sure they look good to you, and we're going to click next. Let's talk a little more about dot gain. Dot gain is kind of a standard, right? 20 is kind of a standard that we use. You are able to change this if you would like. Most people use this after the profile is all built to do any curve adjustments that they want to do to the entire print environment. You can do that here. But in general, the dot gain is just set to 20 and it stays there. So that's what we're going to do as well. We're just going to leave it. Next, and this is just information about your linearization that we just did, and we're going to click finish. And that concludes the second linearization chart, measured in, applied, limited, and we're ready to move on to the next step. Next, we need to find out what our total ink limit is going to be. The total ink limit is used in your ICC creation, which we'll talk about when we get into Color GPS later. But if you go into the calibration menu and go to test images, you will see total ink limit charts down here. I recommend using the top one. It's called Total Ink Limit A4 Gold 1. I'm going to open that, and this is what it looks like on screen. So let's print this out.
What you want to do to find your total ink limit is when you're printing your chart, you need to examine it as it's printing or right after it's printed. If you're doing dye sub, you don't need to sublimate it. Just look at it on the paper, because what you're really looking for, you're going to examine this very closely and look at the lines between the gold and the black and look around everywhere to see if any of it looks bad. What do I mean by bad? Is the black bleeding into the gold, or is it a nice crisp line? Is there pooling? Is the bottom way too wet? Is there way too much ink on here? Right? Certain areas might look good. So it's a little hard to show on camera, but what you're looking for is the numbers on the side here, 200 to 400 and 200 to 400. What you're looking for is at what point does it stop looking good? On my chart, I see some bleeding on 320, a little bit on 310, but not much. So I'm actually going to use the 300 ink limit. So this is for the total ink limit when you build your ICC profile.
Now that we selected our total ink limit, we're going to open up Color GPS. It is in our calibration menu, Color GPS. And once that opens up, you should have your print environment listed here by default, because that's the one that you've been working on. But just make sure that this is set to the environment that you've been working on. And now we can go to create the actual chart. Click next. And in this window, we have some settings that we have to set up. The top one is our total ink limit. By default, it's set to 300, and that's what we got from our total ink limit chart. It was 300. You also need to set GCR. Now, GCR can be set to none, or you can set it manually, or you can choose one of the options. So what this is are we going to use cyan, magenta, and yellow ink to create a gray color, or are we going to use black ink? So black ink, if you're using black, it's only one ink, right? So it's cheaper than using CMY, but using CMY, you get a nicer shade, and you can get a lighter shade of black or gray without it being a bunch of big dots that you can see. In my experience, I always recommend using GCR2. It says black in dark tones. So if you're printing an image and you have a black color, it's going to use black ink. But if you have a deep blue, it's also going to use black. But if you have like a nice, maybe a nice skyline and there's some medium blues up there, it's going to use CMY to create any grays that it needs, as opposed to using black. So I recommend using GCR2. You can use GCR1, but that's going to use more ink. So like I said, it's kind of a balance of what you want. If you have a gray ink or a light black, you could try using 3 and 4, but you might just want to try 1 and see how it looks, basically. User defined, you're able to make your own curve here. So if you feel like it, you can give that a shot sometime. We are going to use GCR2. Now we have to select how many patches are in our calibration chart. We recommend, I would say, a minimum of 1,000, maybe 1,500 to 2,000. We're going to pick a medium precision here, and we're going to click calculate. For the demonstration, I'm going to use a smaller number, so I'm just going to use this amount. If you would like to, you can click test chart size here, and it'll tell you how many charts you're going to have. So you're going to have 2 pages. It's going to be 10 patches per row, how many rows on the first page and how many rows on the second page. So then we're going to hit print. And it does basically the same thing as the linearizations. This will automatically generate a chart. There's no editing of this chart, so it's automatically going to rip. You can see it in the bottom right, and it printed. And then when you print out the chart, then you can measure it in. Click measure. And then what you do is you go through the whole process of measuring like you normally would a linearization, except again, this is going to have different colored patches. I've already measured that, so I'm going to load in my data. And then once it's measured and you're happy with it, you make sure all the colors are accurate. You make sure that the red patch came out with 2 measurements of red. You want to look through the colors and make sure blue is blue and yellow is yellow and red is red, right? Hit OK. And then from here, you can see that we have it measured in. It says show measurement, so you can actually go back in and look at your measurement if you want. So then you click here, generate profile, and it's going to be 2 processes. This should take maybe 5 minutes or so, 2, 3, 4, 5 minutes, depending on your computer. Once the profile is generated, this window will pop up, and this allows you to take all this information here and copy it over to here, or you can edit this and put any information you want. So you just hit OK. This will finish. It gives you this little message. The ICC was created. It was embedded into your print environment. It's telling you basically it's not saved as a separate file. It's embedded into your print environment. Let me show you that right now. So we hit OK and we hit finish. So this is our print environment. If we go into the settings of the print environment, you'll see now we have this information, and this is the same information I just showed you, how it has ink limit, GCR2. Down here it has your linearization, right? So this is the information that is embedded into your print ICC profile. And see here it says embedded. So you are able to export it if you would like, and then you could use it for whatever other purposes you want to use it for. Once that's done, hit OK. And now you're ready to print some test prints, do some testing, print out whatever you want to print to test, see how good your profile came out. And that's the end of the process.
Excellent. Well, very helpful, Mike. This is going to be extremely useful for anyone that's either roughly familiar with the process in Ergosoft or doing it for the first time. Certainly, as always, if anyone has any questions, please contact us, and thanks for watching.